Hello guys, hope you all are doing well. So in the continuation of the previous gate series, we are solving the questions of gate 1991 and we have completed the questions of 1991. Today we will solve gate 1992 and we'll start from section B. So the very first question is question 11 in the section B. So without wasting time, we'll go into the question. So what question is saying? The concentration of SO2 in the flue gas from a boiler was found to be 0.2 kg per meter cube at NTP at normal temperature and pressure. Determine the concentration of SO2 in parts per million by volume at NTP. Assume that the gases are perfect. So normal temperature and pressure, we know that the volume of the gas is 22.4 meter cube per kilomole and liter per. Or if you want to convert it in liter, then it is 22.4 liter per mole. Okay. So actually, this question is to check the dimensional analysis of a student if you are able to convert the from one dimension to other dimension. Okay, so solution, we have to find the concentration of SO2 in parts per million by volume, and we have the concentration of SO2 in kg per meter cube. Okay, not even the perfect concentration. Perfect concentration is kilomole per meter cube. So very first we have to convert it into kilomole per meter cube. That is the perfect concentration. So we know that at NTP the volume of gas is 22.4 meter cube per kilomole and the molecular weight of SO2 is 64 kg per kilomole. We know that. So divide 0.2 kg per meter cube with the molecular weight. So we have divided. What we will get? 0.2 kg per meter cube divided by 64. That is the molecular weight of the SO2. Kg per kilomole. So kg will cancel out and it will give the perfect concentration, that is kilomole per meter. That is 0.003125 kilomole per meter. Now, we want to convert it into parts per million. So we have to make this concentration unitless. We know that the at NTP the volume of gas is 22.4 meter cube per kilomole. So multiply 0.003125 kilomole per meter cube with the 22.4 meter cube per kilomole. So we have multiplied. See, meter cube will cancel out, kilomole will cancel out. We know that now in this step we have multiplied and divided 0.07 with 10 to the power 6. We have multiplied 10 to the power 6 and we have divided 10 to the power 6. We know that 10 to the power 6 is million. Now, final answer we will get 7000 ppm. This 10 to the power 6 will be multiplied with 0.07, that will give 7000, and this 10 to the power 6 that in the denominator we will call as million. So parts, 7000 parts per million will be the final concentration. Okay. Now coming to the next question. This question is very important, and if you don't know the stoichiometry and the process calculations, the basics, then it will give some difficulties to you. So let's go into the question. The analysis of gas entering secondary converter in a contact sulfuric acid plant. We know that for sulfuric acid production, DCDA is the process, double absorption, double contact, double absorption process. DCDA, double contact, double absorption, is the production process of sulfuric acid. So it is given for the gas entering the secondary converter, that is the inlet gas contains 4% SO2, 13% O2 and 83% N2 on volume. Volume percent equal to mole percent equal to pressure percentage. We have solved these kinds of question in the previous lecture as well. And we know that for sulfuric acid, the catalyst uses vanadium pentoxide. There is a four-step catalytic converter, four-step bed catalytic converter, in which the SO2 is converted to SO3, and in a four-step process, then we absorb the remaining gas SO3, the product SO3 with the oleum. That will then the final concentrate. Then the final product is H2SO4. So what question is saying? In the converter, SO2 is oxidized to SO3. That is totally fine. The gas leaving the converter contain 0.45% SO2. That means the remaining gas SO2 which is unreacted on an SO3 free basis. That means this percentage, this 0.45%, we they have calculated on SO3 free basis. That means they have not included SO3. They have not included SO3 while calculating this percent. While calculating this percent. Okay. Okay. Calculate the percentage conversion of SO2. Okay. Good. So very first step, we have a converter. Okay. Gas entering has SO2 4 kilomole, O2 13 kilomole, N2 83 kilomole. How? Suppose we have 100 kilomole of entering gas. Suppose I took entering gas as 100 kilomole. Okay, if I will multiply 4% into 100, that it will give 4 kilomole. 13 into 100, that will give 13 kilomole. And 83 into 100, that will give 83 kilomole. Okay, so that's why I choose 100 kilomole as basis. 100 kilomole of gas entering. Now, we have to find the percentage conversion SO2. We know that percentage conversion, the formula for percentage conversion. SO2 reacted divided by total SO2 fed. Okay, so that is the basic formula. I just write it because so that you can learn this formula. Okay, but we in this question we will calculate the percentage how much SO2 is reacted directly. So the what it means, the gas leaving the converter contain 0.45% SO2 on an SO3 free basis. Free basis, what does it mean? That means amount of SO2 leaving the reactor. Amount of SO2 leaving the reactor, whatever it will be, divided by sum of all the amount of gases leaving the reactor except SO3. We will not include SO3. That is the product gas. This ratio, this whole ratio will be equal to this. It is given in the question. Okay. So, let 100 kilomole or 100 moles of flue gas entering the converter. I will solve as on the basis of 100 kilomole because kilo is just a number. It is 10 to the power 3. Okay. So, that is what defines. SO2 in the flue gas 0.04 into 100, that is 4 kilomole. Similarly, 13 kilomole O2, N2 is 83. Very first thing, N2 is a inert component. It will never react with any of the components. So whatever the N2 is going in, the same amount will go out of the reactor. Okay. So that is the N2 will be same. Okay. Now let fraction of SO2 converted. SO2 converted. Let x. Oh, sorry, x. Fractional conversion. That is, this value will be in decimal. Since x is converting and we are feeding 4 kilomole of SO2. So SO2 reacted will be 4x. This amount is converting and this is feeding. So 4 into x will be reacted. This amount will be reacted. SO2 unreacted. We have fed this and this much is reacting. So the remaining will be unreacted. Okay, remaining will be unreacted. Okay, so this is the first component at the converter's end here. Okay, this is the first component. Second, we know that the stoichiometry SO2 plus half O2, that gives SO3. Okay, so O2 reacted by the reaction 0.5 stoichiometric coefficient of O2 divided by 1 stoichiometric coefficient of SO2 into the amount of SO2 reacted, that is 4x, so 2 kilo. We have fed O2 13 and this much O2 is reacting, so O2 is left 13 minus 2 kilo will be there. This is the second component of the converter. And the third component is nitrogen. Third component nitrogen, because it is inert, so it remain as it is. So now SO3 reacted 4 kilomole. How? Because 4 kilomole SO2 is converting to SO3. Okay, so stoichiometric coefficient of SO3 divided by the stoichiometric coefficient of SO2 into 4x into 4x. So this amount of SO3 produced. Okay, now putting all the values in one, we have this equation as one. Okay, this, this is one. So we have put it all the values. Okay, so see here 0.45 divided by 100, that is 0.45%, is equal to this much amount of SO2 is unreacted upon the all the component at the end of the reactor excluding SO3. We will not consider SO3. So this plus this O2 plus N2 at the end of the reactor. Similarly, if I have 4 subjects, 3, 4, and I want to calculate the percentage of first subject, but want not I don't want to include second subject. So 1 divided by 2 plus 3, right? I don't, sorry, 3 plus, I don't want to include second subject. Then I want to find the percentage of first subject. Okay, so 1 divided by 3 plus 4. Similarly, I want to calculate the uh, concentration of SO2 at the end of the reaction, not including SO3. Okay, so this is given 0.045. So on calculating, the value will be x. Okay, so this is the final value. So the percentage SO2 converted 89.35%. So hope you understand this question. So if you have any doubt, any problem, just comment it below. I'll reply as soon as possible. So take care guys. Bye.